Done. I want to rattle the answers for a second time. I'm just reading the answers. Good luck keeping up. 1/2, 1/4, 3/4, 2/3, 1/10. 1/2, 1/5, 1/4, 3/5, 3/4. 2/3, 9/10, 1/2, 3/4, 1/4, 2/5, 2/3, 3/4, 1/3, and 3/5. I want you, while you're correcting, see how you did on your Power Up Mental Math section. $5, 36 cents, $3.60, 165, 125, 16, 12, 5. And here's the problem solving. Problem solving reads like this. If a 9 by 9 inch dish of casserole serves 9 people, how many 12 by 12 inch dishes of casserole should we make to serve 70 people? They gave you a hint, there's going to be some leftovers. Now guys, some of you said, well, a 9 by 9 serves 9, so a 12 by 12 serves 12. That's going too fast. Here's what I need to do. I need to figure out how much area is in a 9 by 9 pan. So I take 9 times 9, and that gives me 81 inches. Now I take the 81 square inches and I divide it by this 9, and I'm back to each person eats 9 squared inches. Now I'm down here. 12 times 12 is 144 square inches of casserole. I divide by this 9 because that's how many inches each person eats. That goes in there once, 9, 5, 4, boom, 16. A 12 by 12 inch casserole feeds 16 people. Now I need to take my 70, that's how many I need to feed, and say, one pan feeds 16 people, how many pans I need to feed 70 people? So I take 16 into there and I get 4. 4 times 4 is 24, 4 times 6 is 24, carry the 2 is 6. Well, I subtract, I got this 6. That means 6 people didn't get to eat. I can't have that. My answer isn't 4. I need to add one more pan on there. I also can't say it's 4 and 6/16. I can't make 6/16 of a casserole. I have to make it in full 12 by 12, guys. So I take 4, round up to 5, and say you need to make 5 pans of casserole. So, number 1. Can you see that you had to do this division to figure out how many square inches a person eats? Number 2, then do the math and divide to see how many people this feeds. Number 3, do the division, and then 4, have the math logic to say add one more, because right now 6 people aren't eating. I got to have more than enough food, not enough food. All right. Yesterday in lesson 16, we were working with the U.S. customary system. Temperature, lengths, capacity, even weight. We had to know all those numbers and work with those, and we messed with, at the end, function tables, like a sequence that we just do the multiplication or the addition over and over again to get those. Today we're measuring angles with a protractor. So hopefully you have one of those protractors. If you don't, I'll teach you a way to get close without carrying a protractor around, because not too many of us carry these fancy protractors around in our back pocket so we can measure angles. And so I'll teach you a way where we can guesstimate something close to that. Let's get going with our lesson. You have your yellow folder out. You have your Power Up flipped over to the back side so you can just work through a few sketches, and we are ready to rock. Top of page 115 says this. In lesson 7, we discussed angles and classified them acute, right, obtuse, or straight. In this lesson, we'll begin measuring these angles. Angles are commonly measured in units called degrees. The abbreviation for degrees is a small circle written above and to the right of the number. A full circle is 360 degrees. Memorize it. We're going to use it all the time. Half circle divided by 2 is 180 degrees. 1/4 of a full circle would be a right angle. A right angle is 1/4 of 360 degrees, which is 90 degrees. All right. Thus, the measurement of acute angle is less than 90 degrees. The measurement of obtuse angle is more than 90 degrees, but less than 180. An angle that measures 180 is called a straight angle. You and I call it a line. The chart below summarizes these wonderful things. So you got the acute, right, obtuse, and straight. Those are all in your book for you, okay? In your yellow folder, I wrote this: degrees, measurement used for angles, and, well, we also use degrees like yesterday when we were talking about temperature. So we use degrees for temperature too, guys, and we also use it for angles. Then I gave you the three ones they gave you: full circle 360, half 180, right 1/4 of a circle 90. We have all our labels. Okay, bottom of the page, the last paragraph says this: a protractor can be used to measure angles. As shown on the following page, the protractor is placed on the angle to be measured so that the vertex is under the dot, circle, or crosshairs of your protractor. So guys, what they're saying is you got to put the point not at the bottom underneath this. This is a ruler on the bottom. I don't know if you can see that little circle here in there. You got to make sure you're getting it and putting the center of the angle on that circle, and then the line goes right down that line drawn there to be able to do those things. That's what they're saying to you there. And one side of the angle is under the 0 mark at either end of the scale factors. Okay, turn the page. The measure of the three angles shown are as follows. I go from A straight down the line to that bullseye, the circle in the middle, and up to B, and it equals 30 degrees. Now, how did I know it didn't equal 150? Because it went through the number 150. Guys, the first thing you do is you look at the angle. It's acute, so it's got to be the smaller number. If it's obtuse, it's the bigger number. Is one way to think about it. The other way you can think about it is from which direction you come in. In other words, when you come in from the right here, it's the number on the bottom. When you come in from the left, it's the number on the top. I find that confusing, so I always look and say, what's my angle? It's acute, it's the smaller number. It's obtuse, it's the bigger number. I think that's easier. You do what works for you. The next one, AOC, goes from the right to the middle up. You can see it's an obtuse angle. That's why it's 110. The last one goes AOD. It's definitely obtuse, so it's even bigger, and it goes through the 150. Okay, now they'll just read to you that last paragraph what I tried to explain. Notice there are two scales on a protractor, one starting from the left side, the other from the right. One way to check whether you are reading from the correct scale is to consider whether you are measuring an acute or an obtuse angle. So what they're saying is acute, small, obtuse, big. Let's practice. It says find the measure. First we're going from AOB. So I go from A to O to B. Now guys, it didn't go through one of my numbers. Below it, the first step is saying acute or obtuse. It's acute, so I'm picking the smaller numbers. Here's 40, here's 50. What's halfway between 40 and 50? It's 45. So the first angle is measuring 45 degrees. Next one says, please measure A to O to D. So now I'm going A to O to D. I notice it's obtuse, so I pick the bigger number. That's the 140 degrees, not the 40. Then I have letter C, it goes EOD. This one comes in from this direction, guys. E to O to D. That one's acute, so I pick the smaller number. That one would be the 40 degree one. So make sure you understand what side you're coming in from to be able to measure those. Example 2 says use a protractor to draw a 60 degree angle. Okay, those of you who have protractors. Step 1, I draw a line straight underneath it, so I have a straight line. Step 2, I put my protractor on that line with a dot centered on the bullseye. Then I find the 60 and the 120. So I want the smaller one, so I leave a little mark at the 60 here. Now I spin my protractor just to use it as a ruler, and off I go. This is a 60 degree angle. If you want, you can write that in there so that your teacher knows you just drew a 60 degree angle. Now I'll make it a little darker for those of you so you can see it. So that's a 60 degree angle. Okay. The other way to do this, guys, if you don't have a fancy protractor, is to think about this. A full circle is 360 degrees. I have a clock that has 12 hours on it. Okay, so if I take 360 and I divide it by 12, that goes in there 30 times. So every hour on the clock is 30 degrees. So if I was drawing a 60 degree angle and I didn't have a protractor, I would say 12, 1, 2 o'clock. And I draw my 60 degree angle like that. Now notice I drew a 60 degree angle, turn it. But you can also think of times and try to count by 30s. Each hour is worth 30 degrees is one way to try to work those things, okay? Your protractor work, guys, is good. It's easy when they have it drawn, and then every once in a while they'll make you draw things. The other angle they like to make you draw is a 45-degree angle. So if I have a right angle, I just cut a 45, is cut directly in half to get you your 45-degree angle. It's good to be close, guys. This is a good skill to know how to use those things, but in all honesty, none of us are carrying this around in our back pocket and saying, hey, what's measured angle? Hang on a second, let me pull out my protractor. We have to learn to estimate those things. So your clock thing might be a good skill for you to have. Many times in your book, they'll have that protractor drawn into you like they do on the page, on the bottom of page 117, so you can just practice that. So I would recommend going through some of those practices if they get it to you. Obviously, IXL will also give you some work practicing those things too. Great way to do it. See you with your answer key from lesson 17 on the iPad. Make sure you have this thing and you got this work being done. All right, 6th grade, here we get going on lesson 17. We start with number 2. A number cube is rolled once. What is the probability of rolling a 5? Well, there's 1 5, and there's 6 choices, so 1 6. What's the probability of not rolling a 5? Opposites always add up to a total, guys, so you just subtract. 6 minus 1 is 5, or still a total of 6. So A, B. Number 4. Columbus set sail in 1492. The Pilgrims set sail in 1620. How many years were between those two? It's just a subtraction problem when we're doing dates in history. So I got an 8. That became an 11. That gives me 2. That gives me 1. That gives me 0. So I have 128 years between Columbus discovering Americas and the Pilgrims landing in Plymouth Rock. Number 5. Which of the following does not equal 1 1/3? Well, 4/3 definitely equals 1 1/3 by top in, bottom out. 1 2/6 definitely equals 1 1/3 as I reduce it. I see right now that I have my answer, guys, because 4/3 equaled 1 1/3, therefore 5/3 cannot equal 1 1/3. Okay, so that equals 1 2/3. So I got an answer of C. Number 7, write numbers as reduced fractions. So I started with 12/16. I divided by 4 over 4. Divide by 4 on the top gives me 3. By 4 on the bottom gives me 4. I this time have a mixed number of 12/18. I'm dividing by 6 over 6. 6 divided by 6 into 12 is 2. 6 into 18 is 3. Don't forget your whole number, 3 2/3. 25%, I remember that 25 percent means out of 100. The easiest way to think about this is how many quarters are in a dollar. Hopefully you have this one memorized, that it equals 1/4. Number 8, at the grocery store, Len put 5 apples in a bag and weighed them. The scale showed that it weighed 2 pounds 8 ounces. What's this weight in ounces? I know that there are 16 ounces in a pound. I know that I have 2 of them. So I multiply and get 32. Now he also had 8 more ounces, so I have to add those 8 ounces back in there to get 40 ounces. Number 9, find equivalent fractions. So I have 2/9 times equals something with an 18. That tells me this is 2 on the bottom, so it's 2 on the top, which gives me 4/18. Next one, I have 1/3 times something, gives me an 18 on the bottom again. 3 times 6 gives me 18. Do it to the top, gives me 6/18. And this time I have 5/6. Times gives me an 18 on the bottom. I know that this is a 3, so I put a 3 on the top and get 15/18. Number 10, use a protractor to draw a 30-degree angle. So guys, you get your protractor out, you draw your straight line with it. Then you put your bullseye here, find your 30 degrees, and you draw your 30-degree angle. If you don't have a protractor, you're thinking clocks. Remember when we studied this, there's 30 degrees in every hour. So I come out of the 12, I move up to the 1. Now your angles are the same, guys. They're just spun 90 degrees. And so get in the habit of being able to estimate angles like that. Number 11, what factors of 20 are also factors of 50? So 20 looks like this. 1, 2, 4 goes with 5, 2 goes with 10, and 1 goes with 20. 50 looks like this. 1, 2, 5 goes with 10, 2 goes with 25, and 1 goes with 50. What number's in both lists for letter A? Well, 1 is there, 2 is there, 5 is there, and 10 is there. What's the biggest one for B? 10. Jumping to number 15. Missing something in addition. I subtract. So I have $25. I have to subtract $6.30 from it. 0, cross out. 10, 7, decimal point. 14 with the borrow. 8, 18, $18.70. Flipping my answer key over. Number 18. I have 3 and 5, 6. Minus 1 and 1, 6. Subtract the numerators, 4. Denominators stay the same. Subtract my whole numbers is 2. Reduce by dividing by 2 gives me 2 and 2/3. Number 21. I'm doing 55 times 55. That gives me 25. 25 again is 27. Add a 0, and the numbers are the same, guys, because it's the same multiplication. Do the addition, and I get 3,025. 22, parentheses says add it first. So I got 8 plus 6 is 14. Now you have a problem that looks like this. Next to parentheses mean multiply. So 2 times 14 is 28. And we'll label it inches because of the label inside the parentheses. 25, I have 1/2 times 4/3 times 9/2. Multiply the tops, you'd get 36. Multiply by the bottoms, you'd get 12. And 12 goes into 36 3 times. Those of you who are good at canceling, I'll just show you this again and again until we actually get the lesson. If I can do it on the top and the bottom, would look like this. Divide by 2 leaves me a 1. Divide by 2 leaves me a 2. Numbers are the same. Cross them out and leave 1s. 3 goes into 9 3 times. I only have this 3 on the top, 1's on the bottom. 3 over 1 equals 3. So this is going to be a bigger answer with multiplication when I multiply, and then a bigger division problem. These are smaller division problems and then easier multiplication. So you want to get in the habit of doing this. We haven't had the lesson yet, guys, but start practicing that stuff. 26. The cost of the meal was $15.17. Loretha gave the cashier 20 1/4. Name the fewest possible number of bills and coins she could get in change. So make sure you read that carefully. A lot of 6th graders write down $20. No, they gave her 20 1/4. So it's 20.25 going in minus 15.17. Cross that out. That gives me an 8. Gives me a 0. That gives me a 5. Okay, so she gets $5.08 back, but the question is name the fewest number of bills. She gets 1 $5 bill. She gets 1 nickel. And she gets 3 pennies. And 29. Write 3 3/4 as an improper. Multiply is 12. Add is 3 is 15 over 4. Then write the reciprocal of that. Flip it over, guys. 4/15. So those are your 2 answers.